Yeah, that is pretty accurate. Hoping that you could see my screen. And yeah, I'm just going to assume that you can. Anyway, yeah, as Brent said, my name is David Khorshid. I'm at David KPN. I'm pretty much everywhere. And I was working at Microsoft, and now I'm working at Stately. And I'm really excited to talk about what exactly we're doing at Stately, but also state machines. And more importantly, we just saw the joys of coding. So I want to talk about not coding, or at least not coding as much. And so that's why this talk is about code without code, the future of development, or at least what I think is a future of development. So first of all, we've had two great talks about like FigJam and Blender, and like these are great examples of low code tools. But I want to know, like, as a developer, what comes to your mind when you hear the phrase low code? I mean, maybe it's the drag and drop tools or WYSIWYG editors, and maybe it's just tools in general that are intended for non-developers, or as I like to call it, citizen developers, which are developers who they might have an idea of what they want to build, but they don't have the formal coding skills necessary to build that tool. But mostly for us developers, when we think of these like simple low-code tools, we mostly think, no thanks, I can just do everything in code just fine. So to me, what the first thing that actually comes to mind is Visual Basic 6. And this is actually where I learned how to program. I picked up a book on number theory with Basic, and I really wanted to try out the programming examples. So I saw Visual Basic, and I learned that Visual Basic and Basic aren't exactly the same thing, but I was still able to work through some of the example programs there. And I just found Visual Basic so interesting because you could create these visual interfaces, user interfaces visually, you add buttons and timers and all sorts of really cool stuff. And so for me as a teenager with little programming knowledge, this was just really magical to me. I could create simple programs and games like both visually and with code. But I was also amazed at all of the complex programs and games that others were creating with Visual Basic as well. I saw someone make like a fireworks display to full games to just these advanced applications. And that's because, Visual Basic is a full IDE. So this was honestly one of the most exciting times for me as a beginner programmer. I could make simple programs in Visual Basic. I also used Macromedia Flash to visually make these like silly stick figure animations. It was really fun. And I also used Dreamweaver eventually to create websites visually. And of course, you could dive into the HTML and CSS, but because of how they were generated, you typically wanted to avoid those things. But yeah, so these were just some of the low-code tools I got started with, and they're really what made me love programming. Just knowing I could go from a simple visual UI to more complex programs in Visual Basic, from some keyframes and tweens to interactive animations with action scripts, and from static home pages and dynamic websites in Dreamweaver, like just using CSS and JS. It felt like there were just so many possibilities with these tools. But eventually, I actually became a professional junior developer. And so what did that look like? Well, it looked like code, and just code for the most part. So as the programs and websites that I worked on became more complex, the more the developer environments for me just became code. And so this sort of makes sense because websites are HTML, they're CSS, and they're JavaScript. So they're basically three files. You just have to upload them via FTP, and you're up and going. And the low code interface was just like opening your browser window and pressing F5 and seeing it reload all the time. When I forget what it's called, like browser reload or something, came onto the scene, that was actually really exciting because it's like, oh, hey, I don't have to manually refresh all the time. But yeah, I also did a lot of work on WordPress sites, and even for WordPress sites, you had this nice, you could call this a low code interface for creating your websites, but eventually you needed to dive into the PHP to make custom templates and plugins. And pretty soon that's where the majority of my development was while I was working on WordPress sites. But this isn't a bad thing though. This was just the nature of low code tooling, because there's a point where complexity outgrows low code solutions. And that point is often when the capabilities of low code tools aren't really sufficient for what you need to accomplish. And then it becomes a choice of choosing between low code tools, if they exist, for the specific use cases that you need, or just coding, since code is pretty much the lowest common denominator. And what you could do with low-code tools, technically you could also do with code. So as a developer, why consider low-code tools at all if we could do pretty much everything with code? And the reality is that as developers, we are still using low-code developer tools more often than ever before. But the majority of our development is pretty much still centered around code. Now, I read this great article called "The Case for Developer Experience," and this is Jean Yang who wrote this, and she writes that the core conflict of developer tools is abstraction versus complexity. In general, she says that there are two categories of dev tooling: abstraction tools and complexity exploring tools, with most tools belonging to the former category. The abstraction tools assume that you are coding within a vacuum, and complexity tools complexity exploring tools rather embrace the nature of coding in complex environments. So abstraction, as you might know, it's a very important principle in programming. We have functions and classes at the smallest level, and then we get to libraries and frameworks. And then, when dealing with external things, we have third-party APIs and SDKs, and all of this makes development more productive. But abstractions are mostly black boxes. And you know this if you've ever tried fixing a bug caused by some abstraction, or, you probably tried everything like searching Stack Overflow, searching GitHub issues, screaming into the void before actually, reading the source code, if the source code was even available. And although abstractions can automate much of what we need to do, we still end up needing multiple abstractions in any given project, which is that nasty spaghetti glue that holds our code together. And so that leads to complexity. So in the article I mentioned, Jean said that developers work in rainforests, not planned gardens. And I love that phrase because it really describes the nature of where we're working. So yeah, in other words, we don't code in a vacuum, and we don't always have a perfect idea of how everything is going to look and be modeled or planned or structured right from the get-go. In fact, software stacks are pretty much heterogeneous, and the bigger the app, the more true this is. And even if we could make sense and have a full understanding of all the moving parts, things will inevitably change. We will use different versions of libraries, have to change things, maybe include different abstractions like using React and Three.js together, use different libraries, or even have different frameworks and languages living in the same project. So the nature of development today is organic, fluid, and complex. We build from the bottom up, and we really hope that our abstractions just play nicely together, and that the ever-growing complexity really just stays somewhat manageable. And this goes to show you that we really lack developer tooling that lets us manage both abstraction and complexity, because the tools that we currently have, for the most part, ignore the other steps in the development process, like modeling, testing, deployment, infrastructure, debugging, and even versioning, which Git is so good at. So how can we bridge these two things with low-code visual tooling? Is this even possible, or are we stuck with the current developer experience? So I just wanted to take a quick look at a few of the tools that other industries are using, and two of them we even saw today. But really, other industries are just spoiled with these really awesome tools. In graphics design, you have Photoshop, Illustrator, Figma, Procreate, which is one of my favorites. After Effects for movies, there's also Affinity Designer, Canva, which makes it really easy to make simple graphics. And so with these tools, you could really just make super complex things. But in other industries, you have this as well. In game development, you have Unity, and this is, I think it's called Blueprints, where you just have this nodes and edges sort of editor for making complex interactions in games. You have 3D modeling tools like you've seen Blender. There's also Maya. There's also AutoCAD and SketchUp for making 3D models. And then even in the realm of websites and apps, like there's Webflow, Bubble, Framer, Squarespace, Wix, all of these different low-code tools for making websites. There's for apps, there's Flutterflow, recently got a lot of buzz for Flutter apps, Clutch.io and Prismic for React apps. And even when you're making Swift or iOS apps, there's the Xcode interface builder. And for Android apps, there's Android Studio. And so these go beyond just code. They're also just very low-code visual interfaces that allow you to dive deep into the code, but also allow you to step back and see the entire picture. So, however, like what we have today is mostly just code, though, or is it? So, like I said earlier, if we just sort of expand this definition of low code a little bit, many developers are actually adopting low code tools and solutions, and they're doing so even more than ever before. And so even if it doesn't look, at least right now, like the fancy visual tooling that we've seen in graphics design and game development and things like that, we're still using a lot of these tools as abstractions for helping us, be as productive as possible. I mean, we have command line interfaces, we have frameworks, of course, to build our apps. Like, when's the last time you built a single page app without one of these frameworks? Even the infrastructure and deployment, which used to, you could still do it in code, but really no one ever really wants to do that anymore, which is why we have cloud service providers like Azure, AWS, and deployment and infrastructure services. We have Netlify, Vercel, Cloudflare, HashiCorp, for Terraform. And even a lot of the representative companies in this conference, like Remix, GraphCDN, Hasura, FigJam, Blender, Zatabase, like all of these really just these are awesome tools. And you might ask, like, do we need all of these tools? And the answer is not really, but the truth is all of these tools save us from writing millions of lines of code and thousands of hours. So, pragmatically, the answer is yes, we do need these tools. And most developers are adopting these kinds of tools, and for good reason. But to me, one of the biggest missing opportunities for developer tooling is actually in collaboration. And collaboration really fits that complexity category. It reflects how software is actually made, not with just developers, but with the rest of the team too, in an iterative process. I mean, we do have tools like GitHub, Code Sandbox, VS Live Share that enable developer collaboration, but I'm more talking about collaboration with the entire team, because the nature of our apps isn't just code. It's also user stories and user flows that are formed from the user stories, the mockups designers make based on those user flows, the tests that we have to write to assert that expected behavior, and also the tutorials that we hopefully have to teach developers, or sorry, to teach users how to use our applications. And so keeping all of these in sync right now is very, very difficult to do, and it's really time consuming. And that's mainly because there's 3 different personas involved. There's designers, stakeholders, and developers. And so, just because there's this separation between all of these different aspects of app development, it becomes difficult to answer questions like, what can a user do in an app? What are all the features? What are all the possible states of an app? How easy is it to add, change, or remove a feature? And is the user experience even optimal? And how can we be sure? How can we measure that? So ever since I was a junior developer, these are questions that I've been really dying to answer. I really actually found the answer in the form of executable models and visual formalisms like state charts and BPMN, which stands for Business Process Modeling Notation. And so what's really interesting about these executable models that I found is that they're visual, which makes it understandable to not only those working with code, but also potentially understandable to designers and project managers alike. But also they're visually exact formalisms. So these diagrams can really map directly to the code implementations. As our own Laura Kalbag calls it, they're not speculative artifacts, but rather they're really visually accurate representations of the code. And to me, that's the key, having a visual language that could be shared with the entire team without any loss of information. Now, I know some of you might be thinking, like, OMG, am I just advocating for UML? And the answer is no, not exactly, because One of the biggest issues with UML, at least back then, was that it required a lot of upfront planning using strict notation and formalism and all these class diagrams and database diagrams. And this doesn't really fit into the developer rainforest of ever-changing complexity that we have in the modern software development lifecycle. We need something a little bit more flexible and lenient, but still fitting that strict, visual, formalism that we could use to both design and develop applications. And so, of course, you might have guessed it. I'm really talking about state machines and state charts. And so these are two of my favorite visual executable diagrams. And these are, what I really think of as a really good common language. And what I like about these is that they could change over time. Now, these aren't the only kinds of diagrams and visual formalisms that you could use, of course, but they're just my favorite, of course. What I really like about state charts, though, is that state charts are basically state machines like this, but they allow for refinement of logic at the lower level for developers, but also make higher level flows visually clear for designers and stakeholders. So you could see the overall picture, but you could also zoom in to each of the states and transitions. For example, we have this simple state machine where we're logged out, and when you log in, now you're logged in. And so to a project manager, this could represent a user story. Given a user is logged out, when they log in with the correct credentials, then they should be logged in. But also, each individual state can contain nested substates that contain implementation details, and the states and transitions can contain things like actions, invocations, guards, and more, where developers can really fill in the blanks with the implementation details. In fact, it becomes possible to use the same state machine that we create not only to enable communication and collaboration between designers, stakeholders, and developers, but to also have this code that lives within this state machine framework be usable in different frameworks and even different languages, because the higher level states and transitions stay the same, and only the lower level implementation details change. And so that's why I think that, executable visual models like state charts serve the critical role of being a common visual language that developers, designers, and stakeholders can use to communicate with each other. You saw this in even in the FigJam talk. You have those boxes and arrows. In a way, those are state machines, and those are what people use, whether they realize it or not, to communicate processes to each other. And to me, this makes the entire software development process more collaborative, because instead of just being a series of handoffs, it's something that, allows collaboration, especially in our remote work environments that, most of us are in today. Although I suspect that a lot of you in Austria are working at the same company, because there are so many of you from Austria. So, but this, just the entire idea of collaboration is one of the biggest reasons why I created X-States. I learned about state machines and state charts about 7 or 8 years ago, and just how powerful a visual formalism they could be. But what I found was really cool was that it wasn't just code. It's something that can be visualized and executed in real world applications. It started off as a way to experiment with, seeing how a state machine would look like in code. But I really also want to see if it could be visualized. And the early attempts were actually successful. So this evolved to a library that is really for both state management and orchestration, and can be used by any framework or even no framework at all. Its purpose isn't to just be like another state management library, but really the purpose for X-State is for developers to have a way to communicate their application logic with the rest of the team without doing any work. But at Stately, we wanted to take this further. With X-State, you could already take the state machines that you write with code, and you could visualize them as interactive diagrams. So what if you could go the other way and create state chart diagrams visually and have the code generated? So I want to take a minute and show you what we've been working on, and I promise this demo will be quick. About 6 months ago, we actually released this visualizer, which allowed you to, let's say you had a machine like this. I'm just going to create a really simple one, where we're playing states, play. Oops. So we have 2 states, pause, So I could just write this code and visualize it. And this could also be simulated in here. So we could say on pause, this should be paused, and this should be playing, sorry, English. And so basically you get the idea. This JavaScript frame, I almost said framework, it's really just a library. This JavaScript library allows you to represent logic like this in a completely visual way. And it's also pretty concise. I mean, writing a switch statement for this would probably be a little bit longer. But yeah, so that's the whole idea of XState, is just taking this and injecting it into your application and having that represent the brain of your application logic, from the overall routing logic to even the smallest components in your app. But what we really wanted to experiment with was actually being able to create that visually. So I'm just going to create a machine here using our new visual editor, and you can see it already comes with a couple initial states. So let's say that I actually want to make a video player. So I'm going to make a video player over here. And this is our stately editor, by the way, which is in beta. So this is actually the first time I'm really showing it off at a conference. So yeah, so let's say that our video player is closed. Let's say that this is one of those video players where you pretty much have to click the video. It's going to go full screen and then it opens. So when we click the big play button, it goes into the open state. And so when we click play, we want a couple of substates. So we want it to be not playing. And we also want it to be paused. And of course, it could go between playing and paused using an event. So we could pause it. So now it's in the paused state. And so we could go back from the pause states to the playing state. So play. And so, yeah, just like a simple sort of toggle. But of course, as you know, with media players, we also have a stopped state because it could reach the end. And this isn't meant to be exhaustive. This is just showing the editing capabilities of this sample state chart that I'm creating. So we could say that, at any time, whether we're playing or we're paused, when we stop the video, it's stopped. And let me just fix this up a little bit. I love this. It's like auto layouts it's like prettier for for application, or for this, whatever. I can't see English while coding this. In fact, I'm not even coding, I'm visually coding this. But yeah, this represents like just our really simple application logic for our video player. And in fact, hold on, let me mark this as a final state so that I could show you that when like this is done, so we could just say when the state is done, it's just going to go right back to being closed. So when the video finishes, it closes again. So in a few seconds, I was able to visually create this application logic the same way that I would do in Figma or in a tool like Draw.io, Lucid Charts, Whimsical, one of those tools. And, it was pretty easy. It's pretty much the same flow. We're just dragging boxes and arrows together. But now you have an actual diagram that, first of all, you could simulate. So I could go between pause and playing, see the events over here. And when I stop, it goes back to closed. Then I could actually take this, and right now it's just JSON, but I could go to my clipboard and actually use this in a real application. So if I press enter here, now I have this in JavaScript or TypeScript, whatever you want. And that same state chart that I created in a few seconds to represent the application logic, I could actually use directly in my application. And so some of you might be wondering, like, okay, we went one way from code to a visual diagram. Now we went from making this visual diagram to code, but can you do both? And so I probably don't have enough time to show it, but I'm just going to tell you, take a look at the XState VS Code visual extension, because it allows you to do exactly that. You could it's a brand new feature in here. And so the screenshot is not the most up to date, but just imagine that the editor is here so that whatever you change in here is reflected in the code. Whatever you change in the code is reflected in there. Our own Matt Pocock gave a really awesome demo last Friday in our office hours, just showing that. So I will find a link and post that to you. But anyway, yeah, you could if you wanted to, you could go to stately.ai/register and play around with this yourself. So right now we are unofficially doing a public early beta. We're going to make a bigger announcement next week, but I really want you to try this out. We have a really long list of features and enhancements that we're currently working on, but we would love to hear any and all feedback from you. And this is just one of the many big visions we have here at Stately, and it's one of the big ideas that XState enables. We have so many other future plans for where XState and the Stately tooling can evolve, such as multi-step forms, server-side automated workflows, auto-generation of docs and diagrams and things like that, model-based testing, simulation, just a whole bunch of things. And we could list probably a dozen more over here. But yeah, so from Visual Basic to the visual editor, we've come full circle, because as software gets more complex, we need more powerful low-code tools that provide abstractions that allow for rapid application development and also give developers the full power of code to manage complexity without sacrificing collaboration with designers and stakeholders and the rest of the team. And that's what we're focused on at Stately. So whether you're using state machines or not, it's time for developers to start paying more attention to low-code tools, because they're only going to get more powerful and useful for any kind of application that you will want to develop. And so with that, thank you, AgentConf, for listening to me rant about low-code and the future of development. We have a Discord, discord.gg/xstate if you want to join the community. And I'm David. That's it.
That was incredible. That new UI that you built looks amazing. Can't wait to play with it. It seems like
thank you.
Other people agree with that as well in the chat. Does anyone have any questions for David? Got some claps, got a thumbs up and a thanks. Got a request to demo the VS Code extension. Okay, here's a question. Okay, kind of a question. What's harder, inventing XState or getting the arrows in the visualization to look good?
Oh my gosh. Getting the arrows for sure. That has been, I've actually had to, read like a couple of research papers on orthogonal edge routing, and just trying to figure that out was such a pain. It's just a crazy problem to solve, because you're battling between, do we want to intersect this node, or do we want to have it find a nice path that avoids nodes? But then you get like this sort of maze-like structure, and then it becomes difficult to read. Yeah. So we just, right now we're defaulting to make it look somewhat nice, and eventually give the user the ability to adjust those arrows.
That makes sense. Yeah, some ability to override it, so you can maybe
plus SVG is a beast. So
Tanya asks, how big is the team?
Right now we are a team of 7. We actually just hired one of my colleagues from Microsoft who's going to be focused on the workflow automation side, and we're really excited about that. And with that said, we are slowly growing, probably making some more official announcements next week. So if anyone is interested, then just talk to me.
Farzad asks, what are Stately plans for solving the communication in teams between stakeholders? That was covered a little bit, but if you have another way you want to approach that.
I love that Farzad asked that, because he actually works here at Stately. But Farzad and I have been talking a lot about like just how useful these tools can be to not just developers, but to designers and stakeholders as well. One of the realizations Farzad and I made, and we've been talking about this for years, is that when project managers are making user stories, they're actually making parts of the state machine. And so we're like, if we could build something that takes those user stories and automatically creates a state machine based on those, then we could basically trick project managers into creating state machines, and have the same common language.
Michael asks, do you plan to support other programming languages as well?
Yeah, we definitely want to. Right now, the priorities have been creating the visual editor, the registry, and all of that. But I have started on X8 Python. There's been people who have been asking for Go and C# a lot. So that is one of the longer term goals, is to support different languages.